Let's review Standard 8 EEA2. We're talking about expressions and equations. There's 3 parts to this standard. The first part, as I've broken it down, is use square root and cube root symbols to represent solutions to equations of the form x squared equals p and x cubed equals p, where p is a positive rational number. The square root symbol looks like this. There's no 2 on it. We know this is square root. The cube root symbol uses the 3 to make sure that we know the difference between the cube root and the square root. X squared means you've got a 2 to it. X cubed, that's what the 3 means. And we're going to stick with positive rational numbers here. You could do negative numbers, but we're not going to do this in an 8th grade course. We're simply sticking to positive rational numbers. So let's start with, what does x squared mean? X squared with the 2 here means we multiply x by itself 2 times. Now here's a table right down here. We're going to fill this out, or we're going to look at this. If I start with 0 and I have 0 squared, that means 0 times 0. 0 times 0 is 0. If I have 1, I start with 1 and I do 1 squared, that means 1 times 1, and 1 times 1 is 1. If I start with 2 and I square it, 2 squared, that means 2 times 2, which 2 times 2 is 4. If I start with 3 and I've got 3 squared, that means 3 times 3, which is 9. 4 squared is 16, 5 squared is 25, 6 squared is 36. These are what we call the perfect squares, and they continue on. 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, on and on and on. Now let's talk about the square root symbol and let's see what it means. What does this mean here? This means the positive square root of x. When you're looking at the square root symbol, it means the positive square root of x. An example is shown right here, where we've got x squared is equal to 25. The opposite of this x squared is to look for the positive square root of it. If I do that, I've got the positive square root is equal to the square root of 25, the positive square root of 25. I've taken the square root of both sides. What I do to one side of an equal sign, I can do to the other. And the positive square root of 25 is 5, because 5 times 5 is 25. What if we look at this example? We've got the square root of 9 is equal to 3. Well, I know that the square root of 9 is equal to 3 because 3 times 3 is equal to 3 squared, and that would be equal to 9. To continue on this particular section, what does x cubed mean? X cubed means x times x times x. X times itself 3 times. So let's look at what perfect cubes are. If I have 0 and I bring it to the 3rd power, raise it to the 3rd power, that's 0 times 0 times 0, which is 0. How about 1 raised to the 3rd power? That's 1 times 1 times 1. 1 times itself 3 times. That gives me 1. How about 2 raised to the 3rd power? That's 2 times 2 times 2, which is 8. And then 3 raised to the 3rd power is 3 times 3 times 3, which is 27. 4 raised to the 3rd power is 64. 5 raised to the 3rd power would give me 125. And we see right here we've got the opposite of that. So what if I take the cubed root of 0? Well, the cubed root of 0 is 0 because 0 times 0 times 0 is 0. The cubed root of 1 would be 1 because 1 times 1 times 1 is 1. How about the cubed root of 8? The cubed root of 8 would be 2, right? Because 2 times 2 times 2 gives you 8. 2 times itself 3 times would give you 8. It's exactly what we're looking at down here. What does the cube root of x mean? We're basically the opposite of x cubed. If you've got x cubed is equal to 8, the opposite of cubing something is to take the cube root. The cube root of x cubed is x. What I do to one side, I have to do the other. So I need to take the cube root of 8. The cube root of 8 is 2. Why? Because 2 times 2 times 2 is 8. How about the cube root of 64? If the cube root of 64 is equal to x, then x is going to be 4. Why? Because x to the 3rd power, 4 to the 3rd power is 4 times 4 times 4. And that gives you 64. Let's look at a couple of examples on this. What if we've got x squared is equal to 121? Then select all of the following that could be equal to x. Well, if we've got x squared is equal to 121, I could take the positive square root of each side, and I wind up with x is equal to the square root of 121. There's one of those answers. Can I take this any further? The square root of 121, the positive square root of 121 would be 11. Why? Because 11 squared is equal to 121. So your answers are A and C. If x cubed is equal to 127, select all of the following that could be equal to x. And I'm going to change colors so we can see this. I'm going to take the cube root of 127. The cube root of 127. See, I'm just taking the opposite of what I've got there. Would be equal to x. So we want to know everything that could be x. What I can do in this case, since it's a fraction, I can start by breaking this down. I can say the cubed root of 1 over the cubed root of 27. Okay? The cubed root of 1 is 1, because 1 times 1 times 1 is 1. The cube root of 27 is 3, because 3 times 3 times 3 is 27. So let's look down here. Oh, here's 1/3. That's an answer. The cube root of 127. That was in our lineup right there. How about the cube root of 1 over the cube root of 27? It was right there. And notice, these two answers don't work because you're talking about the square roots, not the cube roots. Now let's talk about the second portion of the standard. Evaluate square roots of small perfect squares and cube roots of small perfect cubes. Remember, your perfect squares are things like 1 squared is 1, 2 squared is 4, 3 squared is 9, so on and so on. Your perfect cubes would be things like 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, so forth and so on. This one says find the value for the square root of 1 over 64. Well, this is already worked out here for you. I've already done it for you. I can take the square root of 164 and divide this. I can take the square root of the numerator and the square root of the denominator. The square root of 1 is 1. The square root of 64, the positive square root of 64, is 8. My answer is 1/8. Turn around and see if that works if you square it. If you square 1/8, you would get 1 over 64. That's where we started. Let's look at the next one. How about the cubed root of 8? The cubed root of 8 would be 2, because 2 times 2 times 2 is equal to 8. There's something we need to remember here, and this comes straight out of your Eureka lessons, and I boiled it down right here. I've left this for you to read if you want to. It says a positive number whose square is equal to a positive number b is denoted by the symbol, and it shows it to you right here. This symbol automatically denotes a positive number. For example, the square root of 4 is always 2, not -2. The number square root of b is called a positive square root of b. Although x squared equals 4 means x could equal 2 or -2. This symbol is always equal to 2 or -2. The positive square root of x is called a positive square root of x. So this is called a positive square root of x. And the third part of this standard. Know that the square root of 2 is irrational. This is pretty easy. Just remember it. If you're trying to figure out logic in this, let's remember what our perfect squares are. If we've got 1, 1 is a perfect square because 1 times 1 is 1. 2 squared is 4, so 4 is a perfect square. 3 squared is 9, 9 is a perfect square. Let's look at what we could get if we were talking about square roots. The square root of 1 is rational because it is actually equal to 1, which can be expressed as 1 over 1. Remember, rational numbers can be expressed in the form a over b, where a and b are both integers. How about the square root of 2, or the square root of 4? If we've got the square root of 4, that's equal to 2, which can be expressed as 2 over 1. Again, we've got a rational number because these two can be expressed. These are both integers, and 2 can be expressed as 2 over 1. But notice there's the square root of 2 and the square root of 3 that are between there, right? The square root of 2 and the square root of 3 are not perfect squares. These are irrational numbers. If you put them in a calculator, what you're going to wind up with is a decimal expansion that never repeats, never ends. The easiest thing for you to do is to remember that the square root of 2 is irrational. Now let's look at this example they gave you here. Select all of the following that are irrational. 2/3, is that rational or rational? 2/3 is a fraction. Okay, 2/3, first off, 2/3 is being expressed as 2 over 3. That's a over b. Both are integers, so this is rational. And also, if you divide it, it is 0.6 repeating. If the decimal expansion repeats, then it's a rational number. So this one's rational. Square root of 2. If I were to try to find the value on that, I would get a number that repeats. Its decimal expansion, I would get a decimal expansion that never repeats. This is an imperfect square. This one's decimal expansion never repeats. This one is irrational. Just remember the square root of 2 is irrational. How about the square root of 9? Isn't the square root of 9 equal to 3? 3 can be expressed as 3 over 1. This is expressed as a over b. Its decimal expansion would end because it would be 3.0. So this one is rational. How about pi? Pi never repeats. 3.14, and it goes on and on and on. We don't know where it ever ends. It never ends. Hence, pi is irrational. How about negative 16? Can't this be expressed as negative 16 over 1? That's a over b, isn't it? If it can be expressed as a over b, then it is a rational number.